morning. Today we are completing our work on trigonometry, ensuring we are up to speed on parts of the topic covered before the Easter break and the parts of trig covered after the Easter break. I'm going to remind you of work we covered earlier. Finding missing sides and angles in a triangle that is right angled. On the board we have a right angled triangle and we have one of the sides labelled X. Now the challenge is to find the length of X, to find that missing side. So it's a right angled triangle, so you establish that you're going to use SOH CAH TOA since it is right angled. The first step that we agreed would be to label the side that we have and the side that we are trying to find. So we have an angle there. The angle is 40 degrees. So if we mark the side opposite that angle as opposite, so that's the side that is 5 centimetres in length, we will mark that with opposite. The side we are trying to find is opposite the right angle. That's the hypotenuse, the longest side. So we are working with the opposite and the hypotenuse. Having labelled those, the next task is to decide which trig ratio will I use. So you write down SOH CAH TOA and you tick opposite and hypotenuse. Now it's the sign that would link these, so we have made our decision. We're going to use the sign ratio. Now we would write down sine equals opposite over hypotenuse. Then we would use, for our triangle, the sine of 40 degrees is equal to 5 over x. Now we agreed the next thing to do would be to multiply both sides by x. So if we do that, that undoes the dividing by x. So that would be x times the sine of 40 is equal to 5. We multiply both sides by x. Now this is the harder type, where what you were setting out to find was on the bottom line. So there were 2 steps required there. So we now have x times the sine of 40 is equal to 5. It's x on its own that we want. We don't want x times the sine of 40. So to get x on its own, we have to undo the multiplying by sine 40. So we divide both sides. The opposite operation to multiplying by sine 40 is divide both sides by sine 40. If we divide our left-hand side by sine 40, then we are left with x. Divide the right-hand side by sine 40, and we have 5 divided by the sine of 40. So we have now x equals 5 divided by the sine of 40. You pick up your calculator now, and we put in 5 divided by sine 40 equals, and on your calculator you should have 7.778619134. Now we will round that to 1 decimal place. So 1 place after the decimal point, that lies between 7.7 and 7.8. It's closer to 7.8. So we have x is equal to 7.8 centimetres, and that's our answer done. So our revision today is on right angled trig, whereas most of the topic has been non-right angled triangles. Let's look at a second one where we are asked to find an angle. Now on the board there you're asked to find the angle x. First task again is a right angle triangle, so we can use SOH CAH TOA, and the first task would be to decide which trig ratio are we using. Let's begin by labelling the sides. The angle opposite x we label as opposite, and that is the side that is length 4 centimetres. The other side that we have is 5 centimetres. That's the adjacent side. So we are working this time with opposite and adjacent. Let's write down SOH CAH TOA and tick what we have. We have adjacent and we have opposite. So opposite and adjacent, we would select the tan. So having decided it's the tan we're working with and that the tan is equal to opposite over adjacent, we would write down tan x equals 4 over 5. Now it's the tan of x. To undo that, we do the inverse tan. So x is equal to the inverse tan, open a bracket, 4 divided by 5, close the bracket. Now let's put that into our calculator. Lift your calculator and it's inverse or shift tan, and you'll see the inverse tan coming up on your calculator. Open a bracket, 4 divided by 5, close your bracket. X is equal to 38.65980825. If we want to round that to one decimal place, that would be 38.7 degrees. Now we have gone over the right-angled triangle trig. Your task today will be to work out missing sides and missing angles in both right-angled and non-right-angled triangle trig. This is your chance to check that you are okay with all of the topic that we've done, and tomorrow we will move on. Thank you.